Okay, thank you for the opportunity given to us. Now, we would like to explain our work that has a title COVID-19 chest X-ray lung images classification. Today's outline is the first is introduction, then a method, result, applying on Jetson, and the last is conclusion. Okay, let's move into the introduction. Coronavirus disease or COVID-19 is highly infectious disease that has been declared a pandemic by the World Health Organization or WHO on March 11, 2020 due to the degree of its global spread. There is a widespread belief that older persons with underlying medical conditions such as a cardiovascular disease, diabetes, chronic lung disease, renal or hepatic disease, or cancer are more prone to acquire severe illness. Then the reverse transcription polymerase chain reaction or RT-PCR is the major clinical method now used for the diagnosis of COVID-19. It is costly, less effective, and need expert medical professionals. X-ray imaging is a simple technology that might be an ideal option in the diagnosis of COVID-19. So we went to use artificial intelligence or AI to develop the rapid and accurate detection of COVID-19 from chest X-ray images.
Next, I will talk a little bit about the method. This is a pipeline. First, we will prepare the dataset, then try to pre-process it with some method. Then we put imply it into the training model, and finally we test it. Uh, for the data preparation, we use the data from a team of researchers from Qatar University and Dhaka University in Bangladesh together with their partners from Pakistan and Malaysia. They have produced a database for chest X-ray pictures for COVID-19 positive patients as well as the image of pneumonia, which is usually misunderstood as COVID-19 also. So we will have three classes: COVID-19, pneumo, and pneumonia. And we also try to split the data into the training set, validation set, and test set, and the number of images is as follows. For data preprocessing, first we try to normalize the data, then we convert it into the grayscale, then we resize the image into the 150 times 150, and finally we conduct the one-hot encoding for the label. And this is the VGG architecture that we use. This is the VGG 13 with 13 layers of convolutional layers. And for training, we use Python as the language, and the library that we mainly use is the TensorFlow with Keras. The loss function is the cross entropy with 10 epochs, and the batch size is 22. We use Google Colab to train our model.
As a result, after 10 epoch, the training loss was 7.05% and training accuracy was 96.35%, and validation accuracy was 95.04%, and validation loss was 9.78%. In this case, our training accuracy is greater than our validation accuracy, and also the validation loss is greater than our training loss. So after the training session, we use the pre-trained model in our testing data for testing purpose. So we got 96.98% accuracy. So in this case, our model correctly predicted 133 normal images, 116 COVID-19 images, and 41 pneumonia images, but it predicted 6 normal images as COVID-19, which is wrong, and 3 COVID-19 images as normal, which is also wrong.
For applying our project, we use JSON devices that have many sensors in parallel and can run the multiple neural networks on each sensor stream. It also supports many popular AI frameworks. For applying our COVID-19 project, first we install the Miniconda on Jetson device and importing library packages. After that, we import the trained model and testing data. And finally, we examine the results. By doing that, we encounter some problems like importing the library packages. We deal with that problem by installing Mini4gen LT4T ML container. Another problem was that cannot allocate memory in static TLC block problem. We overcome this problem by running these codes in terminal to update the LD preload parameter and restarting the Jetson device. Also, some limitation problem occur on project. As you know, too large data is not supported by Jetson. Therefore, we narrowed our dataset as much as possible, and we only use 18 images for testing and check performance. As a result, the classification test is made successfully with Jetson device. You can see 18 images and accuracy about 94%.
As a conclusion, we want to mention that PC testing and classification result will not be instantly applicable to JSON. Modification is sometimes required. If the code was written outside of the JSON, we must match the tools used on the PC to the JSON with Ubuntu. And too large data cannot be supported by JSON without increasing the memory capacity. Thank you.